Lesson 11.4, multiplying and dividing rational expressions. So our objective today is to simply multiply rational expressions and divide rational expressions. The algebra standard is 7.1. The good news today, we are not concerned with excluded values. You can assume that nothing, no denominators would be 0, so that's always good news. Here are the steps to what you will be doing, no matter whether it's multiplication or division. You're going to end up factoring everything. Every numerator, every denominator that's factorable, you should factor it as low as it can go. Then you go through and you cancel any common factors from top to bottom. After you've done that, you multiply from left to right for the final answer. But you can leave it in the factored form. You don't have to multiply it back. It would be so much simpler for you if you just left it in factored form, okay? I will have to tell you, if it is division, it's just like dividing fractions. You change division to multiplication and you flip the second fraction. That same thing happens here. If it is division of rational expressions, you really make it a multiplication problem, just like you do fractions. You change it to multiplication, you flip the second fraction over. So don't forget about that part of it. You do have to flip it. Okay, so we're going to start off simple. We're going to start off with monomials in our rational expressions. So hopefully you'll kind of get the hang of it here with this. On number 1, it's 7x squared y over 12z to the third times 14z over 49xy to the fourth. So there is a lot of stuff going on here. A lot of stuff. What you're going to want to do is cancel everything up from the top to the bottom. What I would do, I would just start from the left and go through the right all the way across the numerators. Just go left to right all the way across the numerators, and that way you won't miss anything. So I'm going to start with that 7. That 7 I'm going to cancel with the 49, and I'm left with a 1 up there and a 7 on the bottom. I guess I really need to tell you the main thing is this is going to get really messy looking, so you've got to pay attention to what's really left. And if you're working on your worksheet page, it's going to be too small. Okay? And if it's too messy, you're going to end up putting the wrong thing. So you've got to be really, really careful. Okay, next, x squared. If I look, there's 2 x's on the top. I scan the bottom. There's 1 x on the bottom. How many can I cancel out? 1. So this one down here is gone completely, and my x squared would really just become x to the first. Keep going. I've got 1 y on the top and 4 y's on the bottom. How many can I cancel? 1. So this one's gone completely on the top, and my y to the fourth becomes 3. Okay, I'm going to hop over to the next one. Across the numerator, I've got a 14. Well, I see a 7 on the bottom. So I'm going to do this, and I got to change colors. I know you can't do that, but I'm going to cancel. That's going to become a 2, and that's going to become a 1. But now I'm not done. Do you see that? I have a 2 up there, but look, there's a 12. So I'm going to change colors one more time, and I'm going to say my 2 really becomes a 1. What's my 12 going to become? 6. Do you see how you have to keep all that straight? All right, I'm going to switch back to blue because this is where I've been canceling the majority of it. And I've got a z on top and 3 z's on the bottom. So what am I going to cancel? 1. So this z is gone, and the z to the third becomes 2. Do you see what I'm talking about, how messy that is? So as I'm now thinking I've got everything canceled, and I'm pretty sure I do, I have to see what remains. You multiply across the top, and what I can see across the top is an x to the first or just an x with a 1. Well, I'm not going to write that 1, so I'm just going to put x. And across the bottom, I've got a 6, I've got z to the second, and y to the third. So I'm going to try to remember to do alphabetical. So y to the third and z to the second. And that's it. Now, I can't impress upon you enough about how messy that's going to look. So your best bet is to not save space, because you got to see what's really left there. Okay, so do whatever it's got to take to keep it straight to yourselves. You know, don't mistake that you've really marked something out when you didn't. Okay, questions about that? I saw a couple hands go up. Did you get your questions? Did you figure out what it was? Okay. All right, so you will have some like that. Ben? Well, let me do the first one and then I can let you try the second one, okay? All right, so number 2, this one, now we're going to talk about factoring a little bit. Okay, so not just monomials. And this one actually might be a little less messy when it's like this. I think it probably will be. My first rational expression there, the x over the x plus 4, nothing factors. My second one, well, this thing does factor. Okay, if it didn't factor, then we couldn't do this problem. So the x squared we know is x and x. The minus in front of the 32 tells me what? They're different. So plus and minus. I need a factor pair of 32 whose difference is 4. Olivia? 8 and 4. How do you know which one goes where, though? The bigger one goes with the negative, because we want the negative 4. So minus 8 and plus 4. So outer, inner, you test it. Yep, negative 4x. So now I'm going to mark this part out, because really it's not that anymore. Okay? Are we good with that? Now I'm going to change colors. I know you can't do that, but I'm going to change colors to keep track of what I'm canceling. The most important thing I need to tell you about this, the x plus 4, even though there's no parentheses, you got to understand it is really a set. It is not just an x, and it is not just a 4. You could not cancel this x with this x. Do you understand that? The top one's just an x. The bottom one is not just an x. It is an x plus 4. It has a partner with it. It is a set, and it can only be canceled with an x plus 4. All right, this is a multiplication. I go across the problem. I do have an x on the top and an x cubed on the bottom, so I can cancel out something there. How many x's? 1. So this one is gone completely. Okay, nothing there. And then the x cubed would become x squared. And then I can cancel out the set of what, Olivia? The x plus 4s. And I think that's it. So I look to multiply across the top, and the only thing that I see left there is x minus 8. So I'm kind of dropping the parentheses when I do that. And the bottom I see an x squared. So it would be x minus 8 over x squared. What are you thinking?
That's not too bad. It's not as hard as yesterday.
It's not as hard as yesterday. I think you're probably right. I think now that you're kind of used to it, that's why you think it's not as hard as yesterday, but it's kind of the same. This is a little bit longer, actually, but not as hard. You're kind of used to it now. Okay, example 3. Ben, you going to try it then? Or no? Yeah? 13c minus 39. Anything cancel out of that or factor out of that?
Yeah.
What? Take it, a what? Yeah, so I'm going to factor out a 13.
Yeah.
And in parentheses, what would be left?
C minus 3.
C minus 3. So that is no longer 13c minus 39. It's 13 times the quantity, c minus 3. We good with that? Okay. What about c squared minus 16? Ben, what's that look like? What is it? c squared minus 16. It's a binomial. So the only thing that it could be, if it is something, is there's a minus sign. What's that called? Difference of squares. Difference of squares. Are they both perfect squares? C squared and 16?
Yes.
So we're going to do this. So Ben, c squared minus 16, what would that become?
Oh, you put C's on
Both of them with C's, and then,
and then plus and minus
okay,
and then 4.
yep, plus and minus and then 4. So we're no longer c squared minus 16, we're c plus 4, c minus 4. Okay, bottom left, c minus 4, that doesn't go anywhere. And then the last part is the c squared plus 3c minus 18. So we're going to have to do this, Ben. Okay, where am I going to go with that?
Okay, so you put
C's. What's the minus in front of the 18 mean?
different signs.
Different signs. So we need a factor pair of 18 whose difference is 3.
6 and 3.
6 and 3, how do you know which one goes where?
It wouldn't make sense for it to be in the 6 to be in the negative.
It wouldn't make sense for the 6 to be in the negative because it says plus 3c, so the bigger one goes with the plus. So plus 6 minus 3. Good job. All right, so now as I'm looking across, I start with that 13. Is there any plain number anywhere on the bottom that I can cancel out with that 13? Nope, 13 stuck with us. Okay, what about c minus 3? Yep, definitely canceling out that c minus 3. So it's gone, it's gone. What about c plus 4?
No.
Nope, it's stuck with it. What about c minus 4? Yes, so it's gone, it's gone. And now I'm to the end of the numerator, so I'm pretty much done. So I would write my answer because it's a multiplication problem. There's a 13 times the quantity, c plus 4, over c plus 6. And that is your answer. Questions about that? All right. Let's go on. I've got a division problem here. Okay. Now, I believe what I would do here, I'm going to go ahead, in my tree, if you want to help do it, that's fine. I'm assuming that's why your hand was up. It's a division. Let's go ahead and fix that right off the bat. What do I do to fix that, my tree? Okay, so I've got to rewrite it. So q squared minus 11q. Actually, I think I'm going to put it over here so I have room. Q squared minus 11q minus 26 over 7 times q plus 7 over q minus 13. Okay, so we change from division to multiplication and you flip the second fraction. Olivia? Huh? Can you just exit it out? Just mark that out? I guess. Oh, you mean like take that's not your yeah. That problem's not there anymore. Just forget about it. Okay, my tree, what do you see that could factor here? Yeah, q squared minus 11q minus 26. So these would both be q's. What's the minus in front of the 26 tell you, my tree? Different signs. So we need a factor pair of 26 that has a difference of 11. So that would be, okay, 13 and 2. Which one's going to go where? 2 positive and 13 negative because you want the biggest amount negative because of that sign. It's now not that anymore. So you go across the problem. Do you see anything that cancels? Yeah, we're going to cancel out the q minus 13s, but that's it. So my final answer would be, and this is how you'd write it, the quantity of q plus 2 times the quantity q plus 7 all over 7.